very much, Hugh. It's a pleasure. All right. It is a pleasure for me to share this time with you and these experiences, and I thank you so much for this invitation. It's a privilege to be able to connect with you in the other side of the planet. So it is incredible. So thank you very much. And I will share my screen. I have a presentation to introduce you to EOV, but yeah, I will start saying that I come from southern Patagonia, from close to the Magellan Strait, as you can imagine, from a small city in southern Patagonia. And I first realized what desertification was about when I was coming from my college in summer vacation, and I had my ecology course before, and when I went back home, I realized that the land that I loved was blowing away. So from that moment, that was my decision. Was I will devote my career, my life, to see what I can do with the certification. So that was my dream, and that was my passion. And I started working on grassland management since then. I graduated in 1880. And sorry, 1980, no, not so old.
I don't think you're that old, but yeah.
Yeah, 1980, I graduated and I went back home to Rio Gallegos, my city, and I started working as a research fellow. And in 10 years of research, which included grazing trials and some stuff, I thought I founded a solution for that. And we were based on the traditional literature on grassland management, which was the problem is the excess of animals. Overgrazing depends on the stocking rate. So if you graduate stocking rate, you can stabilize and recover and regenerate land. So that was our hypothesis, and many textbooks and papers said that was true, and we designed an experiment that proved the same. So we were pretty confident that we had a right answer for the certification. So we started working with farmers a little bit early in the 80s, but formally in early 90s. And so that was a rush visiting farms. We defined a method to evaluate grassland. So grassland evaluation was a piece of that approach since the 80s. And we went to every farm we could, made that grassland evaluation and said, hey, you have too much sheep. You are overstocked. So to keep your grasslands healthy, you will need to destock 25%, 30%. That was, well, I spent 18 years doing that. And so probably millions of hundreds of thousands of sheep went to slaughtering because of the overstocking that I was diagnosing with my grassland evaluation method. By the end of that period, I would say 2007, 17 years, the farmers said to me, this is not going right. So they started asking, there must be something else. This is not working. We are not progressing here. Because what happened is that every year we needed to destock more. So those that destocked 30% in the beginning of the 90s, they were destocking. In the 2000s, there was destocking 20% more. So it was an endless loss of carrying capacity, no matter what we do with the stocking rate, except with one region, which was a little bit less brittle, and we had a better response. But as a general rule, we were going backwards most of the places. So that is one when I found holistic management. And we started working with it in 2008, and we kept using our grassland evaluation method, which was called the Santa Cruz method. And the Santa Cruz method was used, and we saw something that we never saw before. It was that those grasslands started to come back to life and started recruiting new plants and covering the soil, and forage production increased, and we were measuring all that. So it was easy for our mindset, which was measure the outcome, to detect that holistic management was totally different than continuous grazing and with flexible stocking rates, which was our proposal previously. So so that started to happen. We have a paper, we are writing a paper with the data from 2008 up to 2020. This is a very, very significant set of data with almost 1 million hectares on that database. And in 2015, the Savory Institute required us to provide, to help us to provide a method to measure land regeneration. Before that, in 2011, we developed our own protocol, which was called the GRASS standard, GRASS, and that was made in a project we made together with the brand Patagonia and the Nature Conservancy, the NGO from United States. And so the GRASS standard was born in 2011, and in 2015, the Savory Institute said, we want something like that, but we don't want that standard, we want our own standard. So we worked together with some old-time professionals from the Savory Institute and also with scientists from the Michigan State University, and that is the birth of EOV, which was first released in 2017, and well, now it has grown, and it is applied in 5 continents and in a very consistent way. So this is what I want you to introduce, the EOV as the monitoring method for land regeneration. And we needed this because as regeneration becomes a fancy word or something that everybody wants to use, it may lose its meaning totally, because we tend to use words until they don't mean a thing. So we needed numbers, we needed figures, and so.
Pablo, could I just interrupt you just a minute? One of the things I'd just really like to pick up on and get you to comment on is you made the comment around that reduction, having to look at the reduction in animal numbers to actually bring back as part of your early model.
Yeah.
But the irony of that, as I understand it, is that as you started to introduce those holistic management or the different grazing practices, actually the productivity opportunity in that land increased. So that whole concept of having to take animals off to protect the land doesn't stack up.
Oh yes, I didn't finish that. I didn't finish that point. Thank you, Hugh. Yes, what we saw for the first time in my 40 years, we saw that the land came back, and in average, this is the average of 500,000 hectares in Patagonia, is that we doubled the carrying capacity, the winter carrying capacity of the farms in 4 years, with a huge increase, 30 to 40% in the first season. So that was never seen in our place. We never imagined that nature seemed so slow and so non-responsive. And when we saw that, it was us, that we were really suppressing spring. So we saw things that we never saw before. A lot of recruitment, new plants coming in, plants that were disappeared because of selective grazing were coming back. And in average, we duplicated the current capacity, and that turned into an average increase of stocking rate of 40 to 50%. We didn't increase the stocking rate in the same proportion of the increase in forage availability. So it was amazing, an amazing process. And yeah.
So Pablo, you've been to New Zealand a number of times. You'd see the same opportunity for us with that same kind of change?
Oh, I can't imagine a better place. Yes, you have the climate and the soils, and the most important thing, you have the farmers. We are losing our farmers here. We are losing the people that have the love for the land and the passion and the will to do things better. We have most absentee farmers, people that are not responsive, especially in the South. So I think that the opportunity is huge. It's huge because the natural conditions are right and the social conditions are right. So I think that you could be leaders in this.
Yeah, thanks, Pablo. I better let you get on with EOV.
All right. So what the point is that you need to measure. If you want to say this is a regenerative product, you need to measure. So this is, I will move now and show you a little bit. So what are the reasons? Why do we need to do this? So the farmers are busy people, and they normally are running, following very urgent things. And why do we need this? So is there a real need or not? So let's see. First thing, you need to inform your own management. This is part of what we call the feedback loop, and some others call it adaptive management. You plan using your best information, but you might be wrong, or things may change. Let's say the climate, the weather, whatever conditions change, you need to monitor to see if you are achieving what you want or not, unless you are doing a management without a purpose, which will be very dangerous. So this is informal management. This is to achieve regeneration and to keep learning. So if everybody measures results in his own way, there is no common language that we cannot compare. So to learn, we need to have the same metrics in different places. So we create a huge database from which we can learn more to the future. So there is a lot of discussion about grazing strategies and people that claim things. Instead of discussing in the air, the best thing is to have benchmarking, to have a lot of cases, and to record the management factors that are behind that, each case, and to learn from that. And then the other thing is, still there are some people that say there's no evidence. Everything is empirical. There's no scientific evidence. Although this is not true anymore because several papers have been published in the last years, still, this is not a huge evidence compared with the amount of people that is doing the job on the land. So EOV needs to be strong enough, robust enough to be able to create, to publish papers. And this is important also for policy making and to generate global incentives for regenerative farmers. So many governments and multilateral organizations are not sure that there is something like regenerative livestock production. They don't believe that. And so we need to provide evidence that is scientifically robust to be that way. And the other thing is, what I was talking recently is, if you are doing a good job on the land, you could tell that story with your product. And this is happening now, and many people are claiming regenerative. So you can see, for example, regenerative cotton. Regenerative cotton, this is funny, that you cannot imagine how can you regenerate land with cotton, but everybody will use the word. So we want to support the claim with metrics, not with marketing strategies. And the other thing is, hey, we are maybe 15 years ago ahead of a very severe global crisis created by climate change and biodiversity collapse. This is not a joke. This is happening already, and the world will need to pay the farmers to do the job of cleaning the air and the water and sustaining biodiversity, and that will need to have a value. And for example, from a perspective, someone that lives in Patagonia, I believe that sequestering carbon from the air is more important to the world, for the world, than producing fiber. You can replace wool with cotton or polyester. You cannot replace the climate. And the same with the meat. You have millions of people that don't want to eat meat. They can replace the meat by any other protein. The thing that we will need in less than 2 decades is to be able to clean our planet, and regenerative livestock production has that potential to be part of the solution, not to be part of the problem. So that's a switch that we need. Any farmer in the world that has the potential as you have it, and the capabilities as you surely have it, to change the management, to be able to stock, to recarbonize and rehydrate the soils. You need to store water and carbon in the soils back again, because most of that carbon is now in the air, and the water vapor also in the air. So this is something we need to do. So a lot of reasons to have EOV instead of business as usual and fuzzy indication of what is happening with the environment. So sorry, and the last thing is that these 2 green boxes represent money to the farmer. We need regenerative farmers to thrive, to be prosperous, because that's the way that adoption rates will change. You know, when the farmer, when the neighbor goes to Jamaica for summer, then here many people start asking questions. So this is what we think. And what is EOV? Very, very quickly, is a method that is practical and scalable, that was developed by the Savory Institute, now being applied everywhere. It can be used on livestock, silvopastoral, and mixed crop livestock systems. And as in a pilot mode, we are using EOV on 100 agricultural land, cropping land, and it's working. It is basic, but it's working. And EOV only qualifies land regeneration, cannot be used to support any other claim, for example, about the product. For example, you cannot claim animal welfare or grass-fed or whatever other attribute of the product. You cannot do that with EOV. So you need to, if you want all of that, you need to add more stamps. It's not a single verification system. So, well, it was developed by Ovis 21, the Savory Institute, and Michigan State University. and it has some uniqueness in many senses, in the design, in the scalability, in the fact that it's outcome based, and also in the quality assurance that is behind EOV. So let's move a little bit further. So this is part also of a program inside the Savory Institute called Land to Market, in which we provide regenerative sourcing to brands. So farmers can verify the farms, and then the brands supply source from them, and then the consumer has the opportunity to choose and to vote for regenerative products, and then that sends a signal for other farmers to join. So the criteria for the design, it is outcome based.
Pablo, can I just hold you there again? Do you want to just explain a little bit by what you mean by outcomes based as compared to other kinds of programs?
Yes. Outcome based means that nobody's better than his acts. So we will not ask you if you plow your land or you drill it or you put fertilizers on it. We just focus on the outcome. And you know that the practices can be good or bad depending on how do you do them. And many certifications are based on practices. No, we wanted to, so outcome-based means you will be verified if you have we can detect a regeneration process on your farm. And we won't ask you what were the tools that you used to achieve that. Is that clear?
Yeah, that's good. Thanks, Pablo. And I presume we're going to get a little bit into what it is that we're looking at and how we're measuring that ecosystem function as we go on.
We're going there.
Yeah.
So the other thing was, how can you create a measurement, a metric system that will work in any place of the world? Well, that's not very possible unless you use just a few attributes. But we made something that it's adapted to each ecoregion, so it's tailor-made to each ecoregion. The other thing is, this is non-punitive, it's a learning community, and it's focused on the farmer. So it's coming from grassroots, from the farmer up, not from the top to the farmer. And we have a holistic approach to regeneration. We are not talking carbon alone. We are talking about ecosystem processes in which carbon is important, but water and biodiversity are not less important than that. And we needed something that was scientifically sound. So data coming from EOV should be accepted by a peer-reviewed journal if you wanted to publish your results. But the other thing was, it needed to be the minimal effort. So the beauty of EOV is that the effort has been calibrated to be the less that still scientifically sound. So there is a lot of things that we could be measuring, and there will be probably a lot of things more than we could do, but we wanted to keep the cost and the time under control. So, and maybe this here we are thinking a little bit about carbon, but soil carbon. But if you see what is there in the market, and we have these two axes, one is precision, and one is effort and cost. You have clearly in the voluntary carbon markets, you have the BERA protocols, which are well known, recognized, but they require intensive sampling, so it's expensive, and they have several layers of verification, which adds a lot of cost because many organizations participate on the process. So normally this is expensive and bureaucratic. And then you have now appearing from all places on the world, groups of people that are trying to use modeling approaches or remote sensing to work with soil carbon. And that creates a big reduction in effort and cost, but also a big loss of precision. They are not very precise. And in some places, they are not precise at all. But there is a lot of people working on this side. So where do we put EOV? We put EOV in terms of precision, not far from the BERA, which is the accepted protocol, and far from modeling and remote sensing, because we measure things on the land. This is not the result of a model. And this is a stage of EOV now. We don't see this as a static protocol. We aim in a reasonable period of time, let's say 4 to 5 years, using the data from EOV 3.0, be able to calibrate models and remote sensing, better models and remote sensing, and the combination of both should be less expensive and more precise than current EOV. So this is, to put you in the map, we are trying to be in the happy medium and to try to provide something that is practical and not bureaucratic and less expensive. So it's scalable. Farmers can do it. Small farmers can do it. No problem with that. So what it is, what do we do? Well, we have, I'll go very quick on this. So to start, you need to have a preparatory work, which is done by a hub verifier. Hugh Jelllie is the hub verifier for New Zealand. He needs, when he goes to a new ecoregion, he needs to set that ecoregion. That is a preparatory work that he will do. So we can calibrate the parameters so to be able to evaluate regeneration on that place. And that will adapt to the local reality, so to the special facts of each ecoregion. There's no, that, especially on the ecological health index, that's what I'm talking about. And then you have what you do on the farm, which is 3 things. You need to have a plan, and you have short-term and long-term monitoring. And then you have after-farm procedures, which is farm auditing, benchmarking, verification process. So the Savory Institute will issue a verification certificate that says this farm is regenerating, which is something that you can use to support your claims on your product. Actually, Ovis 21, our company, is selling regenerative wool to United States, EOV verified. So then you have all the things that relate to with quality assurance that are after you go off from the farm. And this is a dynamic circle. We are in version 3.0, but this evolves. We learn on the way, we improve on the way. So this is just, I would say, the best thing we have now, but it will keep changing and keep improving. So I won't make much time on this, sorry. And when you go to the farm, what do you need? Well, you need a plan. And then you have the short-term monitoring, which is done on a yearly basis. Normally, when the growing season ends, in our Southern Hemisphere, this will be likely to be April, March. So here you do the short-term monitoring. This is quick and cheap, but it gives you an idea of if you're going right or wrong with your regeneration process. And then you have the long-term monitoring, which is done, you set a baseline, which will be your reference. And then every 4 to 5 years, you do the long-term monitoring, which includes different variables, and it's more quantitative. It's quantitative, it's more expensive, and but it gives you hard data about regeneration. So what do we measure? Well, the short-term monitoring, we measure ecosystem ecological health index, which is, I will explain, and we also measure forage and availability and quality. Well, in New Zealand, you are experts on measuring this, but in other places, this is something that is still lacking. And we record animal production and management practices every year. So what we are trying to assess is what is happening with ecosystem processes with this ecological health index. And we want to see what is happening with primary productivity or forage productivity. And also we want to measure what is happening with animal production. So this is happening on a yearly basis. And for example, if you're practicing holistic management, this forage availability and quality will help you to calculate your carrying capacity for the winter, and the ecological health index will tell you if you are improving or not. And the long-term monitoring, it requires at least a 2-people team to do it, and it requires measurements more quantitative. So we assess biodiversity by using fixed transects with points. So we get which is the cover of each species and each functional group in a grassland. Then we keep measuring ecological health index. We measure infiltration rate, and we measure soil carbon. So these are 3 critical environmental services like biodiversity, water infiltration, and carbon stocks are measured. And we have, if you have it on your place, you can do also soil health sampling, soil biology tests like a Cornell test or honey test or whatever you have. So these are the measurements. And the important thing with the EOV is that it is applied by the Savory Institute in all the world, and there is a quality assurance behind that. I would say it's not easy, but anyone could write a protocol, a kind of a set of procedures. But the important thing is not only to have the right protocol, but also to be able to apply it properly. And what we have in the Savory Institute is a quality assurance scheme. Sorry, that is worldwide, and it's very important. So each land base, each farmer is verified by the EOV monitor, which is trained and accredited by the Savory Institute. And then you have a hub verifier, which is in charge of a territory. Let's say New Zealand, you have Hugh here. So Hugh needs to oversee what is happening with the land bases and the quality of this data. And he will need to do some farm audits to see if the data coming from these land bases it's okay or not. And if someone is not progressing, the audit will be an opportunity to see what is happening and see how we can help. So all the data, which is the blue arrows here, all the information flow, which is consistent with the same method, goes to a global platform called the EOV platform. So here you have information from farms from all the world coming into the same format, and that is overseen by the EOV QA team at the Savory Institute. So the EOV QA issues the certificates, verification EOV certificates for the farms. So they check the information in the platform, and they check compliance and also outcomes. So this is an important role. And of course, the EOV QA could implement hub audits and visit the hubs and check what is happening there. Besides this, we have a scientific advisory group in which very prominent scientists are members that they revise the versions of EOV and they provide suggestions to how to improve it. And also we have the master verifier group, which Hugh is member of this, which are the EOV verifiers that have more experience and they have producing consistent results. So this is a group of people that have been trained and have been verified in the performance of the work. So that provides high quality data, which is very important to support products in the market or also to trade environmental services, both ideas. So this is the homepage of the EOV database. We have more than 300 land bases at the moment. This started 2 years ago, and it's growing very, very fast. So, so this is that database. So you have, this is the general picture. If you have questions here, I will stop and very glad to answer.
Yeah, thanks, Pablo. That's great. I mean, just pick up on a couple of things. You talk about ecoregions, and it'd be interesting just to explore that a little bit. So these ecoregions are actually created by independent scientific institutes that relate to different geographical and climatic regions within a country. We've got about 23 in New Zealand. But I guess just what it allows us to do is procedurally we do the same or follow the same protocol, whether we're doing that in Central Africa or in Waikato, New Zealand. But the creation of that ecoregion and the context of that ecoregion makes it so we can use that same protocol, and come up with comparative information, not directly, but with regard to the regenerative impact.
Yes. Okay. Do you have more questions that you want me to address?
We've just had a question from the floor. How would ecological health be measured in New Zealand context? Would diversity of predatory terrestrial insects suit? This is from Richard, who's doing a study on this, and other aspects of measurement seem well enough established in New Zealand. Would you comment on that?
Well, yes, the Ecological Health Index, which is the language, the common language of EOV, is calibrated to each ecoregion. But on the microfauna, the assessment is quite rough because Ecological Health Index is a quick appraisal. So in the long-term monitoring, we don't have any assessment of biodiversity of insects. We are assuming that if soil cover increases and biodiversity of plants increases, the rest of the variables will be correlated with that. We needed to define a minimum set of variables, Richard. So we don't have that level of information, which doesn't mean that you cannot locally increase your detail level if you want to. But inside the Ecological Health Index that I am going there very soon, we have a quick appraisal of the activity and density of insects, but it's just visual. And it's very rough. I don't think it's a very precise thing. And at least it forces the observer to put an eye on insects, which something that I spent 30 years without taking the really less than minimal attention on insects. So it is, I think the indicator is too rough, but still we are looking for insects and determining which is the the abundance and activity of insects. And that is part of the ecological health index.
Thanks, Pablo. And just one other question that's come up is that I understand this is outcomes-based, but surely at some point the methods used also need to be verified. You would surely expect to see reduced use of fertilizer, et cetera, over time. I think it'd be good to comment on that. Thanks, Pablo.
Oh, yes. Yes, the most of our farmers are not using any input at the moment. So this is a consequence. But what we do is start managing for biodiversity and mimicking nature and doing that work on basically on the grazing planning, but also using some other tools. And what we see, is a fantastic drop in the level of inputs of the farmers.
I just reinforce though that the point that you made before is that the process is agnostic to farmer activity, but the expectation is that if they want to continue to have an improving health index, their practices will ultimately need to change. Would that be fair?
Yes, that is fair. That the fact that the method, this is the metric. So the method is agnostic, but if you want to see results, you will need to apply regeneration principles that, of course, if you are applying too much chemicals, you will destroy probably many aspects of the soil biology, and you will lose many aspects of soil function that will affect everything. So I don't see any possibility of achieving very good results on EOV without using the practices that we know that work on that. I would be surprised that a high input scheme, unless you are coming from a desert and you are irrigating it and putting a lot of technology, but in the case of a normal grassland or cropping area, I don't expect, and we don't have yet a lot of data to be too sure of that, but I'm pretty sure that it will be very hard to increase infiltration rate, biodiversity, and carbon stocks by using a lot of chemicals. I don't think that would happen.
Thanks, Pablo.
Okay, I will keep showing a little bit. Ecological Health Index, talk a little bit about this. This is quite unique. Imagine that if we didn't have this, you would do your baseline, and then you need to wait 5 years to see what happened with soil carbon, for example. And so the surprise could be very bad. And the problem is that will be a lagging indicator, which you don't have the chance to change anything. If you are taking wrong decisions, how would you know? And well, the Ecological Health Index is something that is quick and cheap. You can create a score from for a place in 5 minutes, let's say, a trained fellow, 5 to 7 minutes per place. So you can go through the farm in very short time and assess Ecological Health Index very quickly. So to see how is the process, you need to define the ecoregion. That is defined. Normally, we take the ecoregion descriptions that are used in the country, so that meaningful for the scientific world. So we don't create ecoregions. We use those that are described and accepted in the region. Then we look for state and transition catalogs, which reflect the dynamics of that place in terms of vegetation and soil. And we look for reference areas, which will be places that show the highest expression of ecosystem processes. And with that, we create evaluation matrix that has been contextualized to that ecoregion. And then we use it in 3 processes, in short-term, long-term, and land auditing. And this is the way, you do this once, you may improve your evaluation matrix as you use it, but normally this is done once, and it's not very difficult. Involves, of course, to do the research of the literature that you have around this ecoregion to understand the state and transition catalog and the potential that you have in that ecoregion. And we have a procedure to use EOV if we don't have this work done. In the case of something you need to solve quickly, you have also an evaluation matrix that uses generic indicators. So to put some image in this, these 2 places are not very far one from the other. And here you can see the reference area for the dry Magellan steppe close to the Magellan Strait in Patagonia. This is my place where I come from. And this is a close farm. This is a state of the land, not very far from this. So what the Ecological Health Index measures is the distance, is the departure from the potential of the site that you have. In this case, you have extreme departure. So this is, if you think about water, what happens with water, or what happens with photosynthesis, or what happens with biodiversity, of course, this is contrasting, and the Ecological Health Index score will show that dramatically. So this has been published. Ecological Health Index correlates, has a strong correlation with some attributes that takes some time to evaluate, as species richness and percentage of bare ground. So this has been published in 2019. So EOV has been validated. This is a correlation between Ecological Health Index and quantitative measurements that are much more expensive than having Ecological Health Index. So if you, in 5 minutes, you can have a high correlation with something that takes you maybe a couple of hours to measure, that's a good one. And so more images. This is Ecological Health Index, high and low, very extreme, Patagonia. And this is in non-brittle grassland. Maybe that this could be similar to yours. And you can see, we can see differences here. And in a subtropical grassland on northern part of Argentina, you can see also negative and positive scores. So it reflects the percentage of bare ground. And well, obviously, this is the indicators that we use. Bare ground is very important. It affects all ecosystem processes. But then we have some other indicators that I won't go into detail, but capping, for example, if you have a crust that is limiting water infiltration, signs of erosion, the abundance of litter, the decomposition of that litter, the existence of microfauna. And here we see evidence of microfauna. Doesn't need to be exactly the insect. You can see also evidence of that. And the rate of dung decomposition, the abundance of litter, those are indicators that are related with the mineral cycle. And with community dynamics, what we do is we define a healthy grassland as a grassland that has all its functional groups present and thriving. So depending on the ecoregion, you will may have warm season grasses, cool season grasses, legumes and forbs, trees and shrubs, rare species that are indicators of the land coming back, and contextually undesirable species will be problem species that want to invade your land, and you're normally or probably spending money to control them.
Pablo, before you go off that slide, could you just comment quickly about the four, we're looking at those four ecosystems processes, or the lenses that we actually look through for each of those headings that you've got there?
Yeah. Yes, of course. In the case of energy flow, you're trying to assess the dimension of the size of the photosynthesis that you have, and that is done by the cover and also by live canopy abundance. This is the amount of leaves. It will be equal to leaf area index. Which is the size of your solar panels at a particular point. So this reflects the capability of the grassland to capture energy from the sun. And this is, let's say, the starting point for most of the other ecosystem processes. And water cycle, of course, if you have bare ground, you will have a poor water cycle normally, but also, well, we assess the abundance of litter. If the soil surface, the status of the soil surface, in terms of if you have a porous, non-compacted soil surface, you will have very good infiltration rate. You know that for a water cycle, the important thing is that water is captured in the soil, stored in the soil, so you minimize evaporation and runoff. And then once you have it in the soil, what you want is that water goes back to the air through the stems of a plant, so through transpiration, because every time you have transpiration, you have photosynthesis and you have primary production. We live on the transpiration of plants, so that is the important thing. And the amount of transpiration will depend on the ability to capture the rainfall. And the max here, what you want is water stays where it rains. It doesn't run off, or it doesn't go back to the air by evaporation. So that is, so if you have litter, you have more chances of wood infiltration. If you have capping, that is a negative attribute. That will happen whenever you have the soil exposed for a long time. The rainfall creates the capping, and then you have your soil sealed, and then water and air cannot move freely. And then, of course, you have erosion in terms of, if you have water erosion, you can track that you have a accelerated runoff, and in your water balance, the water is not infiltrating, is moving from the landscape. So that is very severe. And also you have wind erosion, which will affect your, normally what the particles that are blown away by wind are fine or organic matter or fine particles that will reduce your ability to store water. And then you have mineral cycle. And here, what you want to see, it is not only the amount of litter, which will be part of the feed of the soil, how much of your pasture goes back to the soil, and also how fast that litter decomposes. And then you have an assessment of what's the activity of living organisms. This is microfauna. And so what we are seeing here, well, we are seeing for flying insects, for worms, for spiders, for pollinators, for predatory insects, all those dung beetles, all those organisms that play a very important role in the stabilizing and in the ecosystem. And it is a very rough estimate, but at least we have them in the radar. We are looking for them. And then you have dung decomposition rates, which is, we assess the speed of the decomposition rate of dung, which also relates with feeding the soil, with including not only biomass, but also microbes. So a lot of biological inoculation of the soil through the dung.
Pablo,
And then in community,
we've got
yes?
a couple of minutes. So I just wonder whether there's some other things you wanted to finish off on.
Okay. All right. Okay, we are, yeah, just, I will move quickly, sorry. Well, this is the evaluation matrix. I don't expect you to read these small letters, but it has 5 columns and each indicator is a row. So you have 5 options for each indicator and you have a score for that. So in a farm, what you would do is to have a monitoring plan. In this case, you have short-term monitoring points and soil sampling points on each of these red triangles, and then you have some benchmark sites in which you will be assessing biodiversity and water infiltration. And the trend of the ecological health index is used to verify a farm. For example, these 2 farms here, you can see that they are declining clearly. So they will not be verified by EOV because they are degrading the land. And these 2 below, yes, they have positive, significant trends, upward trends. So they will be verified by the Savory Institute. So a little bit about long-term monitoring. I will go quickly, sorry. The soil sampling details. We have a restricted sampling procedure. We have a minimum of 20 samples per farm, which are distributed according to a stratification of the different types of soil. And each sample is a composite sample of 3 cores, and we want more close to 6 cores per sample. They are taken 0 to 30 centimeters. But if you have equipment and the will to go deeper, that's accepted. And we calculate bulk density by the weight of the intact core. So in the same procedure that you are coring for soil carbon, in the same procedure you are getting the bulk density. And some places where you have stones, gravel, and you cannot do this precisely, then we have a second option, which is the excavation method. And for calculation of the soil carbon stocks, we use the equivalent soil mass procedure, which refers carbon content to a fixed mass. So if you have changes in the density of the soil because of compaction or decompaction, then the results will not be affected. And our procedures follow the Australian carbon scheme published in 2018. And we use the first option for soil analysis is the Dumas total combustion autoanalyzer, but we accept other methods like Walkley Black and loss on ignition. So these are details. This is the shape of a monitor, which has, you have here a photographic post. This is the photographic plot, which has this shape particularly because this is adapted to a 50 millimeter lens. So this is make sure that you always take the same picture. And then you have this transects, which are used for vegetation analysis. And you have this type of monitors in benchmark sites that are distributed across the farm. And this can show you the results. This is in a very dry place on northern Patagonia. And this is how it looks 4 years later using holistic management. And so I'm finishing, Hugh, the last one. So this is a global method to quantify land regeneration. We think that it has the best balance between precision and cost. The short-term monitoring provides cheap and quick leading indicators to inform management. The long-term monitoring quantifies environmental services of crucial importance, like biodiversity, infiltration, and soil carbon. And we have an organization that provides different levels of QA to have consistent data everywhere. And so you can use EOV to create regeneration credits and allow the farmer to participate on voluntary carbon markets, voluntary markets. So we wouldn't take this effort of measuring with such detail on the land if we did not think that farmers need to be rewarded by doing that. And so EOV requires an effort because we expect that the world will pay the farmers to take carbon out the air, to store water in the soil, and to provide refuge and survival to many species that have been endangered by the advance of deforestation, cropping, and improper grazing. So this is, thank you very much.
Pablo, thank you, and yeah, thanks for giving us a, well, I mean, it shows how comprehensive the program is, and I guess we've only, within this time, we've only been able to really scratch the surface of some of those parts and the opportunities. And I guess the exciting things that come out of that is the opportunities for those farmers who get into this program, and something that we'd like to explore a whole lot more with you maybe sometime in the future is this whole area of payment for ecosystem services. But you know, I think it's been a really good introduction, and yeah, as always, learn a lot from you. So thank you for your time, and thank you to everybody who has attended. I think, yeah, a really good introduction. Thanks, Pablo.
Okay, thank you very much, all of you. I wish you the best.
Oh, we'll see you again, Pablo, and you take care and stay,
Okay.
And we'll be in touch. Thank you again.
Thank you very much, Hugh, for the invitation. Bye-bye.